Good morning, dear friends. I am Dr. Reginam Linus from School of Electrical and Communication Sciences at JSPM University, Vagoli, Pune. In the last session, under this modeling of electrical machine series, we have seen how one can derive the equation when the stator is fictitious in the rotor. That means the rotor variables are as such and the stator variables are fictitious. So in this regard, we have seen the three terms in the equations. First one will be the voltage drop due to the resistance, then voltage across the inductance and the speed EMF term. In this session, we are going to learn how one can derive the final matrix of the AC machine modeling when the stator is fictitious in the rotor. In the last session, we have seen the voltage of the voltage equation in the rotor attached reference frame, where the stator variables are fictitious. In this equation, as I told already, there is having t terms. First one, three terms. First one will be the voltage across the resistance and voltage across the inductance and speed EMF term. Already we know in the previous session what is mean by RDQFR, what is mean by LDQFR, and what is mean by GDQFR. However, for making you to understand very easily, so RDQFR is nothing but F into R alpha beta naught into F transpose. Then similarly, that LDQR LDQFR is nothing but F into L alpha beta naught into F transpose. Then another one will be speed EMF term. GDQFR is nothing but F L alpha beta naught into D by in the previous class I have mentioned here T, but actually it is not T, that is D by D theta of F transpose plus F into G alpha beta naught into F transpose. Okay. Now we are going to calculate all those things in order to substitute this equations. So now let me start with R dqfr. This R dqfr is nothing but F matrix is nothing but H0 0 U matrix into resistance matrix. The resistance matrix, we are converting that into 3 cross 3 matrix, right? That means we have 6 cross 6 matrix. We are converting that into 2 cross 2 matrix. Accordingly, the resistance matrix will be RS 0 0 RR, rotor resistance. You should remember H is also 3 cross 3 matrix, U is also 3 cross 3 matrix. Similarly, RS also 3 cross 3 matrix, RR also 3 cross 3 matrix. Then into F transpose is nothing but HT00U. We are going to calculate now. So when we do this, we should know what is mean by HT. H also already I have explained what is mean by H and all. When we multiply these three matrices, we will get HT. We will get the value as HRS HRS H transpose, then 0, then 0, then UR U transpose. Okay. Then now we already know what is mean by UR U transpose. So now we are going to calculate first. What is mean by HRS H transpose. What is HRS H transpose? H matrix. In the previous lesson we have seen, previous class we have seen cos theta r, sin theta r 0. Then we will have minus sin theta r, then cos theta r 0, then 0, 0, then 1, that is H matrix. In the R matrix, we can see RS 0, 0, 0, RS 0, 0, 0, RS. Then we will have this HT matrix with that H transpose. That means H matrix already we know. This is the H matrix. So we can write cos theta R sin theta r 0, then minus sin theta r cos theta r uh, 0, then 0, 0, 1. So this is the matrix of the H transpose. When we multiply this with this further, we will get final matrix. If you do the matrix multiplication, we can write the final matrix as RS0, 0, 0, RS 0, then 0, 0, RS. Then we know already this U is nothing but U transpose, right? U is nothing but unit matrix. So U, this will be, we have to write not, this is RR. So U transpose is nothing but R, RR matrix. Therefore, we can write U R U transpose RR matrix is also, if you do the multiplication, we have RR 0, 0, 0, RR 0, then 0, 0, RR we will get it. So this is the final value of the this matrix. So finally we can write this RDQ, this RDQR is nothing but we can substitute here what is mean by HRS, HRS, H transpose, we can do by URR, U transpose, we can substitute here so that we will get final value as R, R, let me take the another color, R DQFR matrix is nothing but we will have 6 cross matrix RS0, 0, 0, RS 0, 0, 0, 0, RS. Then here we will have 0 matrix, 0 matrix. Then we can have here 0, 0, 0, 0, 0, 0, 0, 0, 0. Then R, R, 0, 0, 0, R, R, 0, 0, 0, R. Like that we will get it. Similarly, when we do this further for the matrix of L alpha beta, L DQ F trans, DQ F FR, right? So when we do this L DQ FR, we can L DQ FR is nothing but already we know F L alpha beta naught F transpose. So from this we can have this as we can already we know what is H, this F matrix. F matrix equal to H 0, 0 U, then L alpha beta naught we can write LS MSR, MSR, then MSR transpose matrix, then LR matrix, then we will have F transpose, that means H transpose 0, 0, 0, U transpose. So this is what the final. So now when we substitute all, already we know what is meant by H0, what is meant by U matrix, similarly LS as well. So when we do this, final value becomes, we will have 6 cross 6 matrix is LS 0, 0, then 0, LS 0, then 0, 0, LS, then here mutual inductance M 0, 0, then 0, M 0, then 0, 0, 0. Similarly here M 0 0 0 M 0 then 0 0 0. Then here LR rotor inductance LR 0 LR 0 0 0 LR. So like that we will do it. Then we have to find out third term. It is speed EMF term. Already we know G dqfr is nothing but f l alpha beta naught into d by d theta of f transpose plus f g alpha beta naught into f transpose. So when we do this further, we can substitute all the values. F matrix is nothing but H 0 0 U matrix. Then L alpha beta already we know LS MSR MSR transpose then LR. Then we will have d by d theta of F transpose H transpose 0 0 U transpose plus F transpose already we know H 0 0 U. Then we will have to write the speed EMF term. Already we know what is meant by G alpha beta. In the previous lecture, if you refer it, you will understand that is nothing but G1, sorry, 0 G1 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 transpose then 0 then we have should have F transpose that is H transpose 0 0 U transpose. Now when we substitute this all the equations we can have the final matrix will be the two terms. First I will multiply this three matrix, then we will have to multiply this three matrix. So this answer will be HLS d by d theta of H transpose, then H MSR and d by d theta of U transpose, then we will have U MSR transpose d by d theta of H transpose, then U LR d by d theta of U transpose. So already we know U matrix is the unit matrix, right? So U transpose is also unit matrix. So similarly we will get here 0, then H G1 U transpose, then U G1 transpose into H transpose 0. So already told you that U matrix is nothing but the U matrix is nothing but unit matrix. So when we do this, automatically differentiation of unit matrix, this term will be 0. Similarly, this term will be 0. So we will end up with this equation as G. Let me go to the next page. So we can write G dqfr equal to, we will have H Ls d by d theta of H transpose into H MSR. Here we have to add this to this, right? We have to add this plus this to just matrix addition, right? When we do this, finally we will get MSR and we will get H G matrix HG1 into U transpose. Then we can have U MSR transpose d by d theta of H transpose plus u G1 transpose H transpose. Then this will be, let me move this to somewhere here. So then here we can write it as uh, u LR d by d theta of u transpose. So like that we have to write. Then finally we have to be calculate individually that this we have to calculate the values of HLS, what is the value, then what is mean by HGU transpose, what is mean by these values and these values, and finally we have to substitute. Already I already we seen this value, already we have made it as 0, this term is already 0, right? Since differentiation of differentiation of ut, so automatically this term will go to 0, so no need to repeat again, this term will be already 0 matrix. So when we do this further, we have to calculate first h ls d by d theta of H transpose. When we do the multiplication, we will get 0 minus LS 0, then LS 0, 0, 0, 0, 0. This is the matrix. Then we have to be write the next value is H HMSR d by d theta of H transpose plus HG1 U transpose. When we do this further, do the multiplication, we will end up with the final answer as 0 minus M 0, then M 0, 0, then 0, 0, 0. So this is the finally we will arrive this equation. Then when final value will be, we have to be add UMSR transpose plus 1 minute. There is one small mistake. Uh, yeah, that is UG1 transpose H transpose. Yes, so this is one mistake. I will correct it now. We are going to calculate again this term UMSR transpose d by d theta of H transpose into this value. So we can write it here UMSR transpose into d by d theta of H transpose plus UG1 transpose into H transpose. When we do this entire calculation, we will be end up with this equation as uh, 0 0 0 0 0 0, then 0 0 0. Okay. Then similarly, already we know this matrix. So now what are the terms we have finished? This term, this terms I have finished, and this is already 0 matrix. Then we did this, right? Then another one term will be HG unit matrix, right? So HG unit matrix we have already derived. So let me HG1 unit matrix already I derived. So the value will be HG1 unit matrix U transpose is nothing but when we do the value 0 minus M 0, then 0 M 0 0, then 0 0 0. Okay. Then we did all the values. What is mean by this matrix and what is mean by HLS, LS in the H transpose as well. I hope already we have divided what is mean by HLS in the H transpose. Then uh, we should write another one variable as HMSR. Yes, so we have finished all, right? So finally, we will get this as PDMF term as, so we will get this PDMF term as, if when we do this, final value will be GDQFR is nothing but we will have 0 minus LS 0 0 minus M 0, then LS 0 0 M 0 0, then we will have the zero terms, all are zero terms only, all are 0 0 0, then we will write 0 0 0 0 0 0. So this is the matrix of GDQ FR. So when we substitute all the values, we will end up with this final matrix. You have to be write it in the matrix form. So we can write this in the final matrix is nothing but VDSF, that means stator is fictitious, VQSF, then VDQ, V naught, V naught SF, then VDR, VQR, then V naught R. So this is the voltage matrix. It is nothing but we can write Rs plus Ls into P, then minus Ls into omega R, then 0, then we will write M and minus M into omega R 0, then similarly Ls into omega R, then Rs plus Ls into P 0, then M into omega R, then M into P, we will have the P also. P means d by dt, okay, into 0. Then we will have 0 0 R S plus LLS into P 0 0 0. Then another one M into P 0 0 R plus LR into P 0 0. Then we will have 0 minus 0 plus M into P, then 0 0 R plus LR into P 0, then 0 0 0 0 0 R plus LLR into P. Then we will have the next matrix is current matrix. Current matrix is nothing but ID yes F IQ SF SF I naught SF, then IDR IQR I naught R. So this is the matrix where a stator is fictitious, rotor is as such. There is no variable transformation of the rotor, but stator variables are transferred to the rotor. So with this, we are concluding the matrix formation. In the next class, we are going to learn, instead of going this tedious process, how one can do by observation this matrix. Thank you.